Welcome back to math. Guess what? We're on module 4, lesson 25. Divide a whole number by a unit fraction. This is a little fuzzy up here, so I'm going to try to explain that as we go. If you notice, we have a box. In the box, we've cut it into two pieces. There's one here and one here, right? Yeah. All right. It says take this box and cut it up into thirds because we have a 2 divided by 1/3 equals. Well, I'm going to cut each one of those up into thirds. 1, 2, so there's 1, 2, and there's 1/3, 2/3, 3/3. 1/3, 2/3, 3/3, so we have 2 whole, right? We have 2 whole divided by 1/3. And what does that equal? Well, how many thirds do we have in one whole? We have 3 thirds in one whole. Now, how many thirds do we have in 2 wholes? Well, we go 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So we have 6 thirds in 2 wholes. Does that make sense? So our answer is 6. Now, what if I did this as a multiplication problem? How if I did this as a multiplication problem? Well, I'd have to take my thirds, right? And I have to flip the right number. And this would become a 3/1. And then I would leave my 2/1 here. And then I'd flip my sign. I'd do the opposite. So 2 times 3 is 6. 1 times 1 is 1. And guess what 6/1 is? It's 6 wholes, right? That's how we got our answer here, right?
Yes.
Does that make sense?
Yeah.
Okay, now another way that we could say this is that, well, we have 2. Let's say we have a box. Now the box is cut up into thirds. So I'm going to cut my box into thirds. Now I'm saying that 2 is inside the third. That's what this third is. Its value or it's worth 2. So I need to put a 2 here, a 2 here, and a 2 here. Guess what that's going to equal? It's going to equal 6, isn't it? So you see how we could do it both ways. We could draw it out, and we can also draw it out like this when we change our problem slightly and say, if there's a 2 in a third, here's my 2, I put it in a third, right? I cut my box into thirds, and then I put a 2 in each box. That gives me 6. And that would be my answer for here. Okay? All right. Well, let's take a look at this one. That one says 4 divided by a half. 4 divided by a half. So what do? I draw my box, and I'm cutting them up into 4 boxes, right?
Yes.
Now I'm going to cut my 4 boxes into what? Halves, right? Do you see the halves?
Yeah.
Okay. So how many halves do I have in one whole? How many halves do I have in one whole? I have 2 halves, right? 1, 2 in one whole box. And I have 4 whole boxes, right? So the question is, how many halves are in 4 whole boxes? Well, we can say this is 1/2 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. So I have 8 halves in 4 wholes, right? Does that make sense?
Yeah.
Great. I'm going to erase this over here on the side because I'm going to use this. This is questioning if 4 is in a half. Okay? I made something, I made it in half, right? How many halves do I have? I have 2 halves. Make 1 whole, right? Now if I say that there's a 4 in each one of these, right? No, that would be wrong. Sorry. I'm going to edit that right out. So if I have it says there's 4 in half. Here's my half. I'm going to put a 4 in this. And do I need to put a 4 in this one? If there's a 4 in half, yes, I'm going to put another 4 in there too, aren't I? So 4 plus 4 is 8. And that's the same answer we got over here, isn't it?
Yes.
Is 8. There are 8 halves in 4 boxes. And if I said there's 4 in a half, I have to draw out my 2 halves, put 4 in each half, add them together, and I get 8. Now, how would I do that? How would I do that as a multiplication problem? Well, I got 4 divided by a half, right? Now, what do I have to do when I'm dividing? I have to flip the right one. Which one's the right? It's the half, right? So I'm going to put it 2 over 1. I'm going to flip my By the way, they're not going around and doing everyone's class. They're only doing one class at a time. Okay. All right, so if I have I'm going to flip my half. I've got 2 over 1. I'm going to flip my sign. What's the opposite of divide? Multiply. Then I'm going to put a 1 under the 4, meaning 4 wholes, right? And then when I multiply across, 4 times 2 is 8. And then I would have 1 times 1 is 1, and this equals 8 wholes, right? So do you see my 8 here, 8 here, 8 here? Those are 3 different ways to do this problem. Okay? Okay, let's try this one now. This says 5 divided by a half. 5 divided by half. I'm going to make my box a little bit bigger, because I want you to be able to see the whole thing. I'm going to cut this box up into how many pieces? I'm going to cut it up into 5 pieces. 1, 2, 3, 4, 5. 5 holes or 5 boxes, and we're going to cut each box up into a half. Okay, now that we've cut our boxes into halves, how many halves do we have? We have 1 half, 2 halves, that would make 1 whole box, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves. That'd be 10 halves. 10 halves. Now how would I check that using multiplication? 5 divided by, now remember, can we divide? Normally we look at dividing like this. What number goes on the inside of the box? The first number goes on the inside. Can we really do a problem that looks like that? Not really. It's kind of a strange way to think about it. But what we're saying is that we have 5 whole boxes and we're going to divide it into half, and that would give us 10 halves. So we don't really do that, do we? By half, we're going to flip the half over. So it's going to be 2 over 1. We're going to flip our division sign. What's the opposite of dividing? It would be multiply. We put a 5 and we put a 1 under the 5 because 5 wholes is 5 over 1, right? We had that earlier in the year. So what is this going to equal? 5 times 2 is 10. 1 times 1 is 1. What's 10 over 1? Or if you like to think of it, 10 fingers is 10, right? Okay. And that's how you would do the checking for your drawing. You could check it using multiplication. How you do the dividing a whole number by a unit fraction. And as always, I love math.